Hello everyone, this is the continuation of our last video of kinematics which we have done in the name of problem solving technique. Now this is our vectors in the plane. So let us solve some problems which may come in your JEE Mains and advanced level problems, and we will build our concept from basics to advanced. A force F has magnitude of 15 Newton. Direction of F is at 37 degree from negative x-axis. So see, the direction of F, this F is in the negative x-axis towards positive y-axis. So in the negative x-axis towards positive y-axis. So the vector F is something like this. Represent F in terms of I and j. So let us say this is our F which is given in the problem, and it makes 37 degree from negative x-axis towards positive y-axis. So what is the component along F? Along F, this is the angle theta which is along negative x-axis. So this is negative x-axis. So the component along negative x-axis would be fx, that is f cos 37, and the perpendicular component would be f sin 37. See, always remember cos 37 degree is 4 by 5 and sin 37 degree is 3 by 5. You have to remember this in order to calculate in competitive exam this type of problem. Cos 37 is 4 by 5 and sin 37 is 3 by 5. So put the values and you will get 12 Newton along negative x-axis. And what is the component of Fy? Fy is f sin 37. Put the value of sin 37, you will get as 9 Newton along positive y-axis. Now how to represent this vector F? See, we got 12 Newton along negative x-axis. What is the unit vector along negative x-axis? That is minus I cap. What is the unit vector along positive x-axis? That is positive y-axis, that is plus j cap. So how to represent this F? From vector's law of parallelogram addition. So you can say that F can be as OM, this is your O, OM plus, if this is ON, this should be ON because they are parallel. So OM plus ON. So Fx multiplied by any vector can be represented as magnitude with its direction. So magnitude along x-axis is Fx, direction is minus I cap, and magnitude of F along y is f of y, and direction is plus j. So we got the vector as minus 12 I cap plus 9 j cap. So this is our second problem. Resolve a weight of 10 Newton in two directions which are parallel and perpendicular to a slope inclined at 30 degree to the horizontal. That means you have to find a component of W, that resolve a weight. You have to find a component parallel and perpendicular to a slope inclined at 30 degree. That means, see, let us say this is the slope, right? This is the slope 30 degree, inclined at 30 degree to the horizontal 30 degree. Now you have to resolve a weight. Let us say this is your weight W. Let us say this is your weight W. So we know you have to resolve this weight W. That means weight is always perpendicular to the horizontal. Weight W equals to mg. W equals to mg is always perpendicular to the horizontal, not to the inclined plane. Weight is perpendicular to the horizontal. That means this W is perpendicular to the horizontal. See, that W is given as 10 Newton. Now see, you have to find a component which is perpendicular to this slope. The question is given, find a component of W to the slope which makes 30 degree with the horizontal. So that means perpendicular component would be this and parallel component would be this. What is the angle of this W and W perpendicular? See, this is the perpendicular, right? If this is perpendicular, then this is 90 degree. If this is 90, this is 30, then this angle should be 60 degree. So this is a right angle triangle. If this is 60, then this angle should be 30 because total angle is 90 degree. Now see, this W perpendicular is attached to W, so that means this perpendicular component will be W cos theta. and this is parallel component, so this would be W sin theta. What is theta? Theta is 30 degree. So W cos 30, W sin 30. This is your answer. Put the values, you will get the answer. So we are moving forward to our next question. Show that this vector A vector is parallel to a vector B. See, we can apply this logic, right? We already know from board logic that A and B are parallel or anti-parallel if A cross B. That means this determinant is a null vector or 0. You can prove like this, but we have another concept by which you can solve this type of problem very easily. The concept is, if two vectors are parallel, then a vector, any vector is a constant multiplied by another vector. Any vector is a constant multiplied by another vector. Let us say, see here A vector is given something like this and B vector is given something like this. See, take 3 common. If you take 3 common, you will see, if you take 3 common from this, so this would be I cap minus j cap plus 2k cap. So we can say that this is, if you multiply it by 1 by 3, if you multiply it by 1 by 3, the vector would be this vector. So we have represented a vector with some constant multiplied by another vector. That vector is your B vector. So this vector, this A vector is some constant multiplied by B vector. So that means A and B are, see, A is 1/3 of B. So this format resembles this thing. So that means A and B are parallel vector. This is one method to quickly solve any JEE problem. If you can't apply this method, apply this method. Two vectors are parallel or anti-parallel to one another if the coefficient of, see, our A vector, let us say this is our A vector, this is our B vector. Take the ratio of individual coefficients. See, A1 by A2, if A1 by A2 equals to B1 by B2 and C1 by C2, both of the 3 ratios are constant, but that means same value. If this constant is a positive value, then the vectors are parallel. If this constant is negative value, then the vectors are anti-parallel. Otherwise, we can simply multiply, take the cross product and prove that it is a null vector. By this method also we can prove that two vectors are parallel or anti-parallel. But remember, these two methods are also important in proving two vectors parallel and anti-parallel. You can quickly solve any problem in JEE and Neet. So let us see some concepts which are extremely important for JEE mains and advanced perspective. See, we already know area of triangle bounded by A and B is half of A cross B, half of mod of A cross B. Area of parallelogram is only mod of A cross B. That means A cross B half is actually area of triangle. Now see, this is a new concept, scalar triple product. This thing A dot B cross C is your scalar known as scalar triple product, and it is the volume of parallelepiped. It is the volume of parallelepiped bounded by vectors A, B and C. So, and you have to remember that this scalar triple product, the name is scalar, so its product is also a scalar quantity. A dot B cross C is same as A cross B dot C is same as B dot C cross A. All of the values are equal. I have already told that scalar triple product is represented as a volume of parallelepiped. If three vectors are coplanar, then the volume of parallelepiped bounded by these three vectors should be 0. If three vectors are coplanar, that means they should lie in the same plane, then their scalar triple product should be 0. That is, their scalar triple product should be 0. If A vector is given as this, B vector is this, C vector is this, then scalar triple product, this thing can be represented as within third bracket A, B, C, no comma, only A, B, C. and this determinant value is write all the coefficients a1 a2 a3 b1 b2 b3 and c1 c2 c3, find the determinant. That determinant will represent volume of parallelepiped whose adjacent sides are along a, b and c. That means a, b and c, volume parallelepiped. You have to write something like this determinant. Let us see the parallelepiped concept which we have discussed in the last section. See, this is a parallelepiped. See, this is a parallelepiped. The vector along this OC is B vector, along OB is C vector, and along OA is A vector. And we know that direction of B cross A, B cross C, B cross C is perpendicular to both B and C. That is, B cross C is here. B cross C is vector this, B cross C. Now, let us say the angle between B cross C and A vector is theta. Then we know that parallelepiped are represented by adjacent sides of three vectors A, B, C. See, here we have taken B cross C. If you have taken here A cross B and this third side OA side is C, then it would be ABC. But we have taken B cross C and A, then our order should be BCA. Our order should be BCA. So we can say that B cross C, this is a scalar triple product, B cross C dot A. Now see, A dot B, let us consider this is A, this is B. So what is A dot B? Mod A mod B cos theta. Mod A mod B cos theta. Now what B cross C represents area of parallelogram, we know, we have just discussed in the last slide. B cross C is area of parallelogram. Now A cos theta, mod A cos theta. Mod A cos theta is the component along, mod A cos theta is the component along B cross C. So this is OM. Now what is OM? OM is the height, right? You see, this is the perpendicular component. So we can say that this is the perpendicular component, this is the height of the parallelepiped. This is the height of the parallelepiped, then it should be the height of the parallelepiped. So this is height. So height into area represents volume. Now this is the volume of parallelepiped. Okay. Now diagrammatically it is extremely important. You have to know the logic behind this. If it is A, if it is B, if it is C, then the order would be A, B, C. Then it would be A cross B dot C, A cross B dot C. Okay. And we have we already know that A cross B dot C, B cross C dot A, all these things are equal. All these things represents volume of parallelepiped. Now remember these two things. Mod A mod B equals to A, then R is A plus B, mod of A plus B, represent this 2A cos theta by 2. If mod A mod B equals to A, then mod of S equals to mod of A minus B. Remember these two results, because these two results are extremely important. If mod A mod B equals to A, if two magnitudes are equal, let us say A, then resultant vector, that is A plus B, would be 2A cos theta by 2. If mod A mod B equals to A, then A minus B, then mod of A minus B would be 2A sin theta by 2. Remember these two results, extremely important. Now see, if they ask you about to find out the angle between two vectors, always come from dot product, not from cross product. Always come from dot product, not from cross product, because we know A dot B equals to mod A mod B cos theta, then cos theta would be A dot B by mod A mod B, then theta would be cos inverse A dot B by mod A mod B. Always come from this logic, from dot product logic. Don't come from cross product logic, because this thing is always not true. This thing is always not true. Though we know that A cross B is mod A mod B sin theta into n cap, but still don't find the angle by cross product, find the angle by dot product. A unit vector perpendicular to both A and B is represented by C vector equals to A cross B divided by mod of A cross B. See, if this is A vector, if this is B vector, then we already know that A cross B is this thing, A cross B is this thing, A cross B is this thing. So this should be the unit vector perpendicular to both A and B. So C vector is plus minus mod A cross B by mod of A cross B. Why plus minus? If it is plus, then it is outward. If it is minus, then it should be B cross A. So it would be minus A cross B by mod of A cross B. Now from dot product logic we know that from dot product, what dot product represents? Dot product represents the projection along another vector. So if this is B vector is A vector, put some light here, then the shadow will represent the component of A on another vector B. So this component would be A cos theta. So if they ask about to find out component of A along B, then it would be A cos theta. Now what is A cos theta? A dot B by B. If they ask about to find the component of B along A, component of B along A, component of B along A, we know A dot B is mod A mod B cos theta. If they ask about component of A, then B should be downward. If they ask about component of A, then B should be downward. See, this is A cos theta because component of A is A cos theta. So A cos theta would be A dot B by B. If they ask about component of B along A, then see B along A, then A is downward. So in which component they ask about, that vector should be in the downward. This is the magnitude, okay, mod A mod B. If A and B are equal, if A and B are equal, see, if A and B are equal, then you have to find out if A and B are equal, that means those vectors are magnitudically they are equal. And let us come to the last point, it is 13. See, if this A vector and this B vector and diagonal is D1 and D2, diagonal is D1 and D2, then diagonal D1 is A plus B, diagonal D1 is A plus B, and A plus B is given by root under A square plus B square plus 2AB cos theta. And if they ask about to find out the diagonal D2, then it should be A minus B. It should be, see, the direction is opposite, so it is A minus B, so it should be root under of A square plus B square minus 2AB cos theta. If those two diagonals are equal, then we have to find out only root under A square plus B square if theta equals to 90 degree. Put theta 90 here, cos 90 is 0, put theta 90 here, cos 90 is 0, then it should be only root under of A square plus B square if diagonal D2 and D1 and D2 are equal. Let us solve some problem. See, find the resultant of three vectors OA, OB and OC as shown. Radius of the vector is given. See, if this is the vector OA, then that component would be OA cos theta. So OA cos 45 is along this, OA cos 45. OA is R, so we can say R cos 45. And component of C along OB is R cos 45, again R cos 45. So we got 2R cos 45. And we have to find the resultant of three vectors. That means we have to add the OB vector also. That means OB vector is what? R. So that means if you take R common, 2 by root 2. Cos 45 is 1 by root 2. 2 by root 2 is root 2. So that is root 2 plus 1. It is very simple. See, the component attached to any vector, is cos component. We already know. So the component of OA along OB is OA cos 45. Component of OC along OB is OA OC cos 45. OA and OC both are radius. So both of them are R cos plus R cos 45. And if you add OB is also R. So you will get the answer. Now see a particle, next question, a particle moves on a given line with a constant speed v. At a certain time it is at a point P. Let us say it is at a point P on a straight line path, in the straight line. O is the fixed point, show that OP cross V is independent of the position P. See, here in this case we have rotated the axis. We have assumed that this is positive x axis and this is your positive y axis. It is given that the particle is moving along x axis and at a certain point, let us say at P point, what would be the coordinate? Coordinate would be x comma y. And what is the distance between OP? You have to find the first. You have to find the position vector. Let us say this is your OP vector, and the coordinate is x comma y. How do we write position vector? OP is your position vector. Position vector is x I cap plus y j cap. This is your position vector. So OP is x I cap plus y j cap. So they are asking about OP cross V. We got OP, and V is, what is V? V is along x axis. So V is the magnitude. Let us say V is the magnitude. What is the direction? Direction is x axis. So I cap. So V I cap. Cross multiply. We know cross product. See, I cross I. We know in the cross product, similar product gives 0. Similar product gives 0. Similar product, similar cross multiple gives 0. And if there this, see, I cross I would be 0. Then comes j cross I. J cross I. What would be j cross I? Apply this method. Ijk. Ijk. So what is j cross I? We are moving anti-clockwise. So it should be minus k. So j cross I should be minus of k. Y into V minus of k. Y is coordinate, so it is constant. V is magnitude, it is constant. So the whole thing is constant. So OP cross V, give the vector. OP cross V is constant. That means it is independent of the position. That's all about vector. And in the next class, we will continue our discussion on projectile motion.